Hey guys, welcome back. So this is just going to be a brief video regarding the material that we're covering on Tuesday. We're going to have a lot of activities that we're going to do in class to talk about reproduction in general and to compare and contrast different reproductive strategies and specifically asexual versus sexual. But what I hope you take away from this is that there's a lot of different ways to reproduce. And even when we say sexual and asexual, the way that organisms can do it asexually is incredibly diverse. So you should be filling out your reading guides in its entirety and do what any good millennial, next gener, digital native student would do. And if you don't see the material in your book under the pages that have been indicated, then go Google it and see what you can find out about that concept. Okay, so just referring back to this diagram from the textbook, we're talking about the 7 key aspects of life that all organisms have to engage in, and clearly reproduction is one of them. If you don't reproduce yourself, then as a species, you are dead. You're effectively done. And reproduction is a key aspect of evolution as well. If you don't reproduce offspring that are viable, you're an evolutionary dead end. So the first learning objective is to compare the advantages and disadvantages of asexual and sexual reproduction. So clearly, reproduction is what we do to make new babies and to make new cells frequently as well. So here we present this dichotomy of sexual versus asexual reproduction. So clearly with sexual reproduction, this is used to make what we say here, used to make different babies. And by that we mean they are different from ourselves genetically. It requires 2 parents by definition, and it's slower because it requires you to find a mate to produce those offspring. In contrast with asexual reproduction, this is used to make identical babies, so your offspring are clones of yourself. So you only need 1 parent to do that. And of course, it's faster because you don't need a mate. You can get right to it at any time. And what you're going to find is that there's many organisms on the planet that can reproduce both asexually and sexually, and there is a definite pattern as to when they might engage in those different forms. So a question that has been a curiosity and a source of investigation for many biologists, particularly evolutionary biologists, is why reproduce sexually? Asexually is fast. You don't need a mate. You can produce, so all of your offspring are capable of also reproducing. You can get your numbers up really, really quickly. So why would you ever engage in sexual reproduction? So a long time ago, John Maynard Smith pondered these questions and talked about some of the pros and cons of sexual reproduction. So some of them are listed here. So sexual reproduction only passes on half of an organism's genes into each offspring. And you know this to be true with humans. So your genetic complement is a combination of half the chromosomes from, or half the genes from your one parent and then half the genes from the other parent, right? So when you reproduce, you're only going to be passing on half your genes with any given offspring. Whereas with a clone, all of them are going to get passed on. Also, only half of the individuals in the population can produce offspring. So in a parthenogenetic or an asexually reproducing population, right, every individual can make offspring. But in a sexually reproducing population, only half can produce offspring. So usually the females, right? So the males can't do it on their own. So these 2 concepts together are what are referred to as the twofold cost of sex. So it takes longer. You're only passing on about half your genetic complement, although there are some variations on that theme. And then only half of the population can reproduce. So why do it? What's the benefit? Well, we're going to talk about that, and you've probably already covered a little bit of that in genetics, and it clearly has a genetic component to it. Taking some of this concept a little bit further and tying it together, so Joseph Muller, many years ago, proposed a concept that has since then been coined Muller's Ratchet. So he proposed that the genomes of an asexual population accumulate deleterious or dangerous, harmful sometimes lethal mutations, and in an irreversible manner. So if you don't know what a ratchet is, we have a picture here, and sadly this is not an actual video, but this is the ratchet mechanism in its entirety. But if you think about it, it's just like uh-oh, what just happened there? Hello, 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 can you hear me?